Between now and 2027, what makes a cloud engineer valuable is going to shift. AI is already doing the work that used to set you apart, which was writing the code, deploying the infrastructure, following the playbooks that have been used for years. And if those are the skills that you're focusing on today, then the market is slowly moving away from you. But the work that AI can't do, which is designing systems and making judgment calls, that's becoming worth more than ever before. And right now, there's a unique window of opportunity where the industry hasn't fully shifted yet. Most people haven't adjusted, and the people who build the right skills between now and 2027 are going to be in an incredibly strong position going forward. I'm Suleiman. I've been in tech for more than 11 years. From IT apprentice to running my own businesses across cloud and AI consulting, my software company StudyTech.ai, and my academy, where I've had more than 900 IT pros, engineers, and career searchers master cloud and land six-figure roles, including at companies like AWS and Microsoft. Now, in this video, I am revealing the 5 cloud skills that will become more, not less, valuable as the market shifts towards AI in 2027 and beyond. These are the same skills that my students are learning right now inside of my academy to get an unfair advantage, and by the end of this video, you'll have them too. Number 1, system design and architecture. System design is the ability to take a real business problem and design a technical solution. For example, a company's checkout page keeps crashing on busy days. A startup needs to handle 100,000 users next month on a tight budget. A finance team has 40 people manually reading documents that could be automated. System design is looking at those problems and deciding how the data flows, what handles the processing, how it scales when demand spikes, what happens when a component fails, and what it costs the business to run. It's about how you put all of these core technical concepts and tools together and link it back to the project brief or the business problem that you're actually working on. And the reason that this skill is so valuable is because no two problems are the same. The same checkout crashing problem at a startup with 2 engineers and no budget looks completely different from the same problem at a bank with strict compliance rules and a team of 20 engineers. The technical options may overlap, but the right answer changes depending on the constraints, on the budget, the team, and the skill sets, right? That's what makes system design really, really hard. It's not just knowing the tools. It's actually understanding which combination of tools makes sense for the specific situation, and then being able to explain why. Now, can AI help with this? Absolutely, it can. You can throw a project brief into Claude or ChatGPT and it'll suggest you an architecture. But here is the problem. AI does not know all of the context surrounding the project unless obviously you feed it in, of course. And any answer it does give, good or bad, if you don't have the fundamental understanding to evaluate the suggestions, then you're pretty much flying blind. You won't know what it missed, what it got wrong, or why one design makes sense over another. And right now, companies are not handing real client projects with real money on the line to AI and just blindly trusting the output. AI in production is still really, really messy. So they will always want, and now more than ever, cloud engineers overseeing these systems. And that's not changing anytime soon. So how do you actually build this system design and architecture skill? Firstly, you need to genuinely understand the core technical components: compute, networking, storage, data, security, AI, etc., right? And the fastest way to learn them is not by memorizing the service names from a flashcard, it's actually by working through real problems. When you start with a business scenario and you try to design a solution, you will naturally look up the services that you need. And because you're learning them to actually solve a problem, they will stick. Your brain holds onto information way better in this way. Secondly, once you've got that foundation, practice designing full solutions from a blank page. Sketch the architecture, walk through every decision, and justify each one out loud like you are in an interview. Because one day you will be, and this is exactly what they will test. Number 2, cost optimization. This one is more important right now than it's ever been before for 2 clear reasons. Firstly, AI tokens and compute costs are skyrocketing. Companies are burning through their budgets faster than they ever expected. Secondly, cloud computing has always had a visibility problem. On average, around 30% of cloud spend is actually wasted, and that's not new. But when you layer in AI costs on top of that, you've got companies burning through money without even realizing where it's even going. And most cloud engineers make this even worse because they treat costs as something that they'll worry about later and focus on building the most fanciest architecture with the latest technologies. But when you design something in the real world and it goes into production, and 3 months later it turns out that you've blown the entire annual engineering budget, it won't just be the project that gets cut, it will be you as well. So Cost optimization is all about designing and running infrastructure so the business gets what it needs without burning money. And it's obviously way more nuanced than just picking the cheapest option. Let's say you've got a server running 24 hours a day, whether it's handling thousands of requests or sitting idle completely at 3 a.m., you're still paying the same amount. So the obvious first move would be to suggest to go to serverless, where you only pay when something actually runs. If nobody's using the system, you pay nothing. It sounds like a no-brainer, right? But serverless comes with its own trade-offs. There's a small delay every time that it starts up after being idle. It also has a limit on how long each function can run. And at a really high volume, where requests are coming in constantly, serverless can actually end up costing you way more than the original 24/7 server that you're trying to save money on. So the obvious cheaper option isn't always cheaper. It depends on how your traffic behaves, how long the work takes to process, and what budget you can handle. And that's what makes this a real skill. Every decision has a knock-on effect and ripple through the whole system. Committing to a long-term savings plan gets you a big discount. But if requirements change 6 months later, then you're locked in and paying for something that you don't need. Over-provisioning wastes money today, but means you don't crash when traffic spikes. Under-provisioning saves money until the site goes down during a promotion and you're losing revenue every minute. You are constantly weighing cost against risk, against performance, against security, right? And the right balance is different for every company. Now, with AI workloads, this gets even more serious because GPUs are some of the most expensive resources in cloud. Uber went through its entire annual AI budget in just 4 months. That's what happens when nobody's paying attention to what's being spent. So how do you develop this skill? Wave costs into your system design from the beginning. It's part of your decision-making process. It's not something that you just bolt on at the end. Every time that you design a solution, you need to understand what's actually driving the cost. Then push yourself. Is there another way that I could build this that's cheaper but still solves the business problem? Because that's the key. It can't just be cheaper. It has to be cheaper and still deliver what the company actually needs. Anyone can save costs by cutting corners. The skill is actually finding the design that costs less, but it still solves the problem. And by the way, if you want my help building these exact skills and you're serious about landing a 6-figure cloud role in 2026, then there's a link in the description below to book a call with my team. We are busier than ever right now because we're getting results virtually every single week. Cosmin got hired as a cloud engineer after 6 weeks with us. Matt went from IT help desk to systems engineer at AWS. Salim just landed a 6-figure cloud role at American Express, earning just under $200K a year. Silas switched careers at 42 and now he's working as a platform engineer. And you've got all of these student results as well. So if you've been watching my videos and self-studying cloud for a while because you want to land a role, then book a call with my team and see if we can help you speed things up. Skill number 3 is cloud security. People misunderstand what cloud security actually is as a skill. Most people think that it's a checklist. You go through it at the end of a project, tick the boxes, and then you're done. It's nothing like that. Security is adopting a way of thinking about every single decision that you make from the very start. When you're designing an architecture, it's not only about making it work. You have to simultaneously ask who can access this, what's exposed that shouldn't be. If this one component gets compromised, what else can be reached from there? And how far can the damage spread before someone notices? Every architecture decision has a security implication. The compute that you choose, how your services talk to each other, where you store credentials, what's sitting in the public versus the private subnets. And here is what makes this genuinely difficult. On the surface, a secure system and insecure system look identical from the outside. Everything works, everything responds, users are happy until someone finds the gap. And now you've got a data breach that will cost a business on average $5 million. And things are getting worse right now, not better. Because of AI, we are all shipping more code than ever before. GitHub's own data shows repository activity has exploded. But the problem is nobody's really checking what's being shipped, at least not at the speed things are moving. Companies are under enormous pressure to get AI features and products into production as fast as possible. And when you're moving at that kind of speed, security is the first thing that gets compromised or deprioritized. 81% of enterprise tech leaders are already reporting production failures tied to AI-generated code. So you've got more code being shipped faster with less oversight. And the result is exactly what you would expect. More holes, more vulnerabilities, and more incidents. And fundamentally, that in itself is a trade-off that companies are actively wrestling with right now. Speed versus security. Ship fast and accept the risk, or slow down and build it properly. And this is exactly why companies are not trusting AI in production without human oversight. You cannot have AI agents crawling through production systems and making decisions with nobody watching or verifying. That is a disaster waiting to happen. So there will be a need for cloud engineers who understand security deeply enough to oversee what's being built and catch the things that get missed. So how do you build this? Get into the habit of stress testing your own work. Every architecture that you design, ask yourself, what if someone gets access to this component? What else can they reach from that? What if these credentials get leaked? How much damage can they do? What's exposed right now that I haven't even thought about? That constant questioning is the skill, and it's what separates someone who bolts on security on at the end from someone who builds it in from the very start. Number 4, infrastructure as code. In the real world, you don't build production infrastructure by clicking through the AWS console. That might be fine when you are learning, but in a real job, every piece of infrastructure is defined by code, stored in files and version controlled. You run a command and it builds exactly what the code describes. Need the same environment for testing? It has the same code. Need to rebuild in a different region? Again, the same code. Everything is repeatable, is consistent, and it's trackable. And this isn't just a preferred way of working. Is genuinely a non-negotiable. Imagine that you've been spending 2 weeks building a production environment by clicking through the AWS console. Every setting, every permission configured by hand. And obviously it will work, but then 3-6 months later, someone will ask you to rebuild it for a different environment. You can't remember every configuration that you chose. You missed something, and now your new environment doesn't match your production environment, which means when something breaks in a testing environment, what a catch. It tells you absolutely nothing useful. Or worse, someone makes a change in production and there's no record of what it was before. That's the kind of problem that causes real outages, and it's exactly what infrastructure as code prevents. Terraform is a tool that dominates this space right now. It works across AWS, Azure, GCP, wherever, right? You write your configuration files describing what you want, and Terraform builds it for you. And here is where things are shifting. AI can now generate production quality Terraform code. You describe what you want in plain English, and tools like Claude, Copilot, Codex will write the configuration for you. Over 40% of organizations are already using AI-generated infrastructure as code tools. So this isn't something that's coming, it's already here. That said, just because AI can generate the code doesn't mean that you should stop understanding it. You can outsource your thinking and executing to AI, but you can't outsource your understanding. 80% of GitHub repositories have now been found to have insecure workflows. And the faster the AI generates code, the more someone needs to actually review it and catch what's wrong before it reaches production and real users, and that person is you. So how do you build the competence here? I would start by building something in the AWS console first, clicking through it, understanding what each service does, how the pieces connect, and get it working. Then you close the console and learn how to rebuild the exact same infrastructure using Terraform. Because when you've built it in both ways, you understand what the code is actually doing. Once you've got that foundation, then you can start using AI to generate Terraform, and you'll actually be able to read what it produces, catch the mistakes, and know when something is off. But if you skip that step and you go straight into AI generated code, you will never understand what you're deploying. Skill number 5 is understanding AI workloads. And this one is a little bit different from the other 4. Up until now, we've covered what has been core cloud engineering skills that translate directly into the AI world. Design, cost, security, IAC, all of those carry across. But now you also need to understand the workloads themselves, because at some point in your career, you're going to be asked to work on AI models and AI systems. Maybe it's scaling one up. Maybe it's deploying a model. Maybe it's figuring out why the AI part of the system is costing 10 times more than expected. That's just where the industry is heading. And having just a basic understanding of how AI workloads work puts you ahead of most people today. So what changes when a workload is AI? Your cloud fundamentals still apply. You're still dealing with compute, networking, storage, security, but the way that the system behaves is completely different. With a normal application, when more users show up, you can add more servers. With AI, the processing runs on specialized hardware called GPUs. They're significantly more powerful than normal servers, but also they are way more expensive. And scaling isn't just as simple as just adding more of them. You have to think about how much more memory that the model needs. You have to look at how many requests are queued up waiting to be processed. And you have to make sure that the hardware that you've chosen can actually handle the model that you're trying to run. You can have everything working fine, swap in a bigger model, and the whole system will break. This is not because anything in your setup and architecture changed, but because the bigger model needs more from the hardware than what is available. The good news is, your cloud knowledge still applies. You're just learning how the rules change when AI is sitting on top of the infrastructure. So how do you acquire this skill? Start learning what AI actually does and why businesses even care about it. Get a feel for what models are and what they're good at. Look at where companies are actually using them. Then find small ways to incorporate AI services and features into the projects that you're already building. Maybe it's adding something that summarizes documents or auto-categorizes data or improves how search works. All you're doing is just taking an existing project that you're already doing or you already built and seeing how you can build AI into it, right? And when you are in a cloud engineering role, you can then really specialize in this AI area if your company requires it. Right, so I promised at the start that I explain why all of this is so urgent. And this is the part that ties the whole video together, so pay attention. Right now, we are in a spending free-for-all. Hundreds of billions of dollars a year pouring into AI. A lot of that has been spent for the sake of it. Companies have been launching pilots because they feel they have to. Proof of concepts that have never been shipped. Budgets thrown at AI because the market rewards the story more than the results. And here is the part that should make you sit up. A lot of that spending is circular. Now let me explain what that means because it matters. Nvidia, who makes the chips, agreed to invest up to $100 billion into OpenAI. OpenAI then uses that money to buy more chips and compute. And a lot of that traces straight back to Nvidia. Nvidia also has a stake in CoreWeave, a cloud company, and CoreWeave provides the infrastructure to OpenAI. So a lot of the same money is effectively just going around in a circle, and every company in that loop books it as growth. The concern here is, and seriously, analysts are raising it, that it creates this illusion of demand. It looks like the whole industry is booming, but some of it is just the same capital being passed between a handful of players. And if that sounds familiar, it's almost exactly what happened with telecom companies right before the dot-com bubble. I'm not saying that this AI bubble pops tomorrow. A lot of the demand is real, but understand this. When conditions tighten, when the cheap money dries up, or investors start actually demanding real returns, that free-for-all will end very, very fast. And then every company outside of big tech, even some inside it, have to answer one question. Is this AI spend actually making us more money or saving us money? Or are we just burning cash? That question is exactly where your job lives. And it's why every one of those 5 skills matter today more than ever. Because when that shift happens, the engineers who keep their roles and get paid the most won't be the ones who built the flashiest demos. They'll be the ones who can design systems properly, keep them secure, see what's happening inside them, control what they cost, and make AI actually pay for itself. The stock market, the narratives, the AI bubble, all of it eventually lands on your desk as the work that you're expected to do. And the 5 skills that I just showed you are exactly what puts you on the right side of it. And look, I know how a lot of you feel about AI right now. Everyone's scared. And that's mostly because you've got people like Sam Altman and Dario going around saying every job is going to disappear. But if you've been paying attention, even they have started pulling back on those statements recently. The reality is a lot more nuanced than the headlines make it seem. And here is how I actually see it. Times like this are a blessing. You can learn faster than ever before. You can get more done than ever before. There are more opportunities right now than there have been in years because all of that spending means companies are desperate for real engineering talent. I am literally suffering from this myself within my own companies. There's a massive shortage of great talent right now. And that's also why we are pumping out results inside of my academy, because we are creating first principles cloud engineers who don't just follow instructions. They learn how to solve real problems from scratch. So yes, it's completely up to you. You can sit on the sidelines and miss out, or you can take advantage of the biggest window of opportunity that we have ever seen. As always, I'm rooting for you. Go and become undeniable.